Alright boys, I just want to do a little update here. I have some things to go through, of some breakthroughs and just updates on the robot project. Okay. Okay, one thing I wanted to talk about is I had this idea. So if you guys recall, we left off here with this Archimedes pulley system. Um, and basically the string would come over here across this top pulley, it would come down, it would come around, it would come around this. Wait, no, it would come around this bottom one, it would come up, then it would come through this second pulley, it would come down, then it would come through this pulley, then up and tie off. So basically, these two would be moving and these two would not be moving at all. And by wrapping the string one continuous wrap like this, um, that first pull was able to be reduced. Because if you just came through like this and came down and up and then tied it off, the total draw distance would be bigger because the string's just going one wrap. Basically, we want the motor to reel in about 10 inches of string, and we are going to reduce that to about half an inch of total draw. And so that's a 20 to 1 reduction. Okay, if we want half inch of total draw, and we want like a 60 to 1 reduction, then half inch times 60 would be it. So we want 30 inches total draw. Okay. So maybe my numbers are off. I'm not sure. I guess 30 inches of total draw sounds about what it is. I wasn't planning to do that much though. So I could be wrong. Or maybe half inch is what is throwing me off. Maybe I wasn't planning to do that much total draw, but maybe I do want to do that much. That's even more reason for what I'm about to say here. So if you wanted it to be 30 inches total draw, then if it comes down around one pulley and back up, that means that this first loop needs to be 15 inches long. Well, that's over a foot. That would mean the entire forearm of the robot would be just that first thing, um, that first loop. But we want um, the pulleys to be no longer than this. In fact, we'd prefer it to be shorter than that even. And this is a 2-scale humanoid. So that's how long we'd want the entire Archimedes system that we're looking at here to be in this profile, but preferably shorter. So anyways, that first loop is the one that travels the most. The other ones don't travel near as much. This is the before, this is the after. You can see these don't travel near as much as that first one. The whole point of the pulleys is each pulley travels half as much as the pulley before it. So this one travels the most and the last pulley travels the least. So my idea, because that first 30 inches that needs to be pulled through this tube on the top, the starting tube, because you got to delete 30 inches, or maybe less, it just depends, maybe 20 inches, because you have to delete a lot, then having the string just go one through one pulley and then tie off would mean it has to be super long. But if you have the string go through and then through, then it can, the string's moving way less in terms of vertical distance because you're wrapping it around and around. And so the vertical distance is less. Yeah, yeah, I believe that principle does hold. Because, like, if you've pictured the snatch block system, or like a real complex pulley block, if you just have this wrap and wrap and wrap and wrap and wrap and wrap and wrap, then this one, however long this needs to pull, wouldn't matter. Like, the distance between these two could be pretty close because all the wraps are happening here. And so that's kind of what we want to do, is we want to have a lot of wrapping occurring with a single string, because that string, we need to just buy time with it. We don't want it to get real long. So basically, we want the starting point to bring all these pulleys way up here. And so I'm thinking we add more up here, and we have one continuous string, keep going and going and going and going and going like that. So follow my mouse. It's going to come down, and then it'll go around this one. Is that it? Hold on. It comes down through there, and then it comes around the bottom one, yeah. And then it comes up through here, around this, and then it comes through this one, and then back up, and then ties off. But instead of tying off, what I'm proposing here is it will come around another pulley right here, and it will turn again, and it will scoop up this one, and then we'll add a fourth one up here. It'll go around that and scoop up that one, etc. And I think if we do that, we can bring these 6 pulleys up like to here, and thereby reduce the total height to like half, maybe. That's my theory, that we'd be able to reduce the total height of this by half. But I'm not sure if that's really true. But that's what I think would happen. Especially since these pulleys can be made way smaller in diameter, too. And so you see that eventually, if you're adding like 4 or 5 of these, it's going to come down to here. And you have to have some draw distance. So that might not work with this scale. But if you made these pulleys like just this big, then you get a better picture of what I mean. Because this was kind of, I think these pulleys are bigger than what they'll need to be. Let's see. Oh wait, no, these are 5 millimeters across. Yeah, we got 1 by 3 by 1 millimeter ball bearings. So 3 millimeters would be, yeah, like a little bit bigger than what I highlighted, I think. Because this is 5 millimeters. This is to scale, 5 millimeters. So we would be able to, 3 millimeters would be a little less. But then you've got the string itself. That's 0.2 millimeters. So yeah, it would be like, if this is 5, it would be like this. Okay, so it would be like this big. So yeah, I think. Plus, we could make the pulleys like even smaller this way by a lot too, and maybe put some of these top ones like stacked like pancakes. Like put one here and then one here. I think that's okay, especially since these just rotate, but they don't move vertically. They wouldn't be like rubbing into each other much. We might be able to get away with that. I mean, we could even use something a little bit more like this design, perhaps. Maybe. Just for the top group or so. Wait a minute. No, we could literally use this design minus the metal stuff on the top at least. Just this bottom section could be Teflon tubing, this vertical part, and then this could just be metal wire, and this could be metal wire. And then the top part we don't need. Well, no, the top part could be TPE tubing again, and then metal wire here cross part. See, yeah. The point is, we don't want like actual brackets. I don't think that's necessary. Metal wire you could just twist together. It'll be easier to thread it through and then just twist it at the top. Or we could use like just string, maybe with like super glue soaked into it to make it stiff. I'm still playing around with those ideas, but then if we're stacking it, we don't want to stack it too thick this way though. But we might have to stack it a little bit this way. The main thing is I'm trying to get rid of a lot more of this space, like the vertical length. I'm wondering. My hope is to cut this in half, vertical length. That's what I think we can achieve, and I think part of that will be. You see how I kept tying these off at the top, because I would have it like after this first one, which goes through looping multiple times, then ties off. The next one ties here and then just comes up and ties off. Same with this one. It ties here, comes up and ties off. And I think by just having one continuous strand that goes through all of them and not having as many tie-off points, just having one string that never stops, that you don't have to travel as far. I think you don't. Now, I know that we could just make it like this and literally do all of our wraps, but then it would get like really thick. Maybe that's two, and then maybe that wouldn't be that thick. Maybe we would go with something more like this then, like three thick. But if the first one is like 1 millimeter thick, this one's 1 millimeter thick, plus like a millimeter between them. 1, 2, 3, 4, 5, 6 millimeters thick. Ooh, that's starting to get pretty thick. But then, okay, because if you guys look here, like we stacked these. Like, because the systems are very flat, we're able to stack an entire Archimedes system here, here, and here. Where you're looking at this whole thing stacked. But if we made it thicker, it would be like this big, but then we would theoretically be able to put two, because it would cut the length in half. Oh, so we're just trading. Oh, if we double the thickness but cut the length in half, then we accomplish nothing. It still takes up the same volume. The point would be to take up less volume. If it gets twice as thick but the length's cut in half, that doesn't really help us, because this length is not really prohibitive. We're okay to have one group and then one group for the forearm. I don't think that length is too bad. That's pretty easy to work with for the robot. It's not that bad. It's only 11 centimeters. Yeah, 11 centimeters long. That's really not that bad. Yeah, that's pretty easy to fit anywhere. It's very muscle shaped. So that's just one design improvement. I'm thinking it could be an improvement is having it wrap more times, and potentially maybe stacking like just two of these next to each other, but not like stacking a bunch next to each other. It starts to get real thick. So that's something I want to play with, and I haven't done it yet. So I'm talking out loud. I'm thinking out loud with you guys right now.